My purpose of this lecture is to make you familiar with some terms and concepts related to hypothesis testing. Basically, I will be giving you a flavor of the meaning of some basic terms, and after that, I will dive deep into these topics step by step in my upcoming lectures. Let's take a situation to start with. Let's say a soft drink company claims that on an average their bottles contain 250 ml of soda, and say you are an officer who has been given the duty to test the claim of this company. Also, let's assume that this company has already paid many fines before due to negligence and false claims on their part. So when you visit the company, you see that there are hell lot of soft drink bottles there. So obviously it is not feasible for you to check each and every bottle. So to estimate the amount of soda in the bottles for the entire population, you randomly pick a sample of 30 bottles and note down the amount of soda in these bottles. And you find that the average amount of soda in these 30 bottles is 200 ml. Well, given this situation, how likely are you to believe the company's claim? Very less, right? This is because if the company's claim is right, then it is highly unlikely that the average amount of soda in 30 soft drink bottles chosen randomly will come out to be 200 ml. Now let's change the situation a little bit. Let's say when you took a sample of 30 bottles, you found that the average amount of soda in those 30 bottles is 245 ml. Now, how likely are you to believe the company's claim in this case? Very likely, right? And this is because the average amount of 240 ml is very close to the average amount claimed by the company, that is 250 ml. Also, note that the company did not claim that all their bottles have 250 ml of soda. They claimed that on an average their bottles have 250 ml of soda. Okay, so we have two extreme cases here. One is when you are not likely to believe the claim of the company, and one is when you are likely to believe the claim of the company. Now, can you tell me at what point between 200 ml and 245 ml you make the decision to believe the company's claim or not? I mean, you must be having a cutoff score in your mind, right? Something like if the bottles contain an average of at least 240 ml of soda, then I'm going to believe the company's claim. But if the 30 bottles have anything less than an average of 240 ml of soda, then I'm not going to believe their claim. And consequently, I will impose a fine on them. So in this case, 240 ml is the cutoff score. The cutoff score helps us in deciding whether to reject the claim or not reject the claim. Let me show you things graphically as well. As we have taken a sample of 30 bottles, so irrespective of how the population is distributed, the sampling distribution of sample means will be normally distributed. Can you tell me why so? Well, it's because of central limit theorem. As we have taken a sufficiently large sample size here, so according to central limit theorem, irrespective of how the population is distributed, sampling distribution of sample means is approximately normally distributed. So let's say this is how the sampling distribution of sample means looks like. Recall that the company's claim is that on an average the bottles contain 250 ml of soda. So if we give the company the benefit of doubt, then that would mean 250 ml is our population mean, right? And we know that the average of sample means is equal to the actual population mean. So this means we can write 250 here. Now the cutoff value that you have in your mind is 240 ml. So let's write it here. You will reject the claim of the company if the average amount of soda in the 30 bottles come out to be less than 240 ml. So let's shade the area to the left of 240. So if average of the sample mean falls in this shaded area, then you will reject the claim of the company, and that is why this region is called rejection region. Okay, so you're going to reject the claim if the sample mean falls in this shaded area. So till now I have given you an idea of two concepts. One is the cutoff value and the other is rejection region. Note that the cutoff value is determined by the researcher. For example, assume that you know the owner of the company. Let's say the owner of the company is your friend, or say he is someone with a good reputation in the society and his company has never paid a fine before. Well, in this case, you might not keep the cutoff value as high as 240 ml. This is because there is always a chance of error as we are working with only a sample. We cannot avoid the error due to sampling variation completely, but the best that we can do is manage this chance of error. In this new situation, because the owner of the company is your friend and a reputed man, and his company has a good brand name as well, so you want to be really sure before you reject his claim and put an allegation on his company. So how will you do this? Well, it's easy. You just set a lower cutoff value in this case. So say in this case you may set a cutoff value of 230 ml instead of 240 ml. So you say to yourself that if the average amount of soda in the sample of 30 bottles is less than 230 ml, then I would impose a fine on the company, and if it's greater than 230 ml, then I will assume it to be clean and I won't impose any kind of fine. As shown here, in this case, because of a lower cutoff value, we will have a smaller rejection region. This smaller rejection region means that you are less likely to reject your friend's company's claim if the claim is in fact correct. Okay, so coming back to the topic, the point that you have to keep in mind is that the cutoff value is determined by the researcher. It depends on how sure the researcher wants to be while testing a claim. The smaller the rejection region, the more sure we are when rejecting the claim. Okay, so if you are clear with this much, then give yourself a pat on the back, as with this you are more or less done with the crux of hypothesis testing. Let me now give you a formal recap of all the concepts that we have learned in this lecture, and then from next lecture onwards I will cover all these topics in detail. In hypothesis testing, we begin by making a tentative assumption about a population parameter. This tentative assumption is called null hypothesis. In our case, we gave the company the benefit of doubt. So to begin with, we assume that the company's claim is correct, and then we tested this claim to see whether we should reject it or not. So in our example, the null hypothesis is that the average amount of soda in the bottles is 250 ml. We denote null hypothesis by H0, and this is how we write it. The alternative hypothesis is the counterclaim. In this case, the alternative hypothesis is that the average amount of soda in the soft drink bottles is less than 250 ml. We denote alternative hypothesis by H1, and this is how you write it. We can also denote it by HA. So you just need to replace this one by small a. Okay. The sample statistic is the evidence that we observe. It is the observed sample average. In our case, it is the average amount of soda in the 30 soft drink bottles. Finally, the cutoff value is the value that indicates when the claim is rejected or not rejected. In our example, we took two cases. First, when you don't know the owner of the company, in this case you set the cutoff value as 240 ml, And second, when the owner of the company is a friend or say a reputed person, in this case you set the cutoff value as 230 ml. Depending on which case we are dealing with, if the sample mean turns out to be less than the cutoff value, then we reject the claim. And if it turns out to be greater than the cutoff value, then we do not reject the claim. So, this is all for this lecture. I hope this lecture has given you a brief idea of some of the important concepts that we are going to cover in this section. It's okay if you have some questions or slight confusions in your mind at this stage. As I told you before, the purpose of this lecture is to give you only an idea of what we are going to cover in this section. So hold your thoughts for a while. All your confusions will be automatically sorted as we proceed further in detail.